In this video, I'm gonna talk about what I've learned so far about software architecture and software stack. It is a high-level overview of software creation process, and in general, it is required to understand the architecture of Instagram, YouTube, and any other social network platform in order to design the Collabshare platform. So let's get started. Welcome to the Collabshare channel. I'm Ramin, and in this video I'm gonna talk about the following topics. But before starting, I'd like to mention that I'm currently going in the direction of my dreams to become a great social entrepreneur and establish a company called Collabshare. In this regard, I just document what I have done toward my dream. So irrespective of any idealization dilemma in my mind and any perfectionism mindset, I will record my progress during each week. So in my videos, I'm just a presenter of my weekly progress with what I've learned and done so far. This approach is courageous to help me create great content and add value to society in a progressive manner. So please remember that everything that I provide here is just an abstract and compressed, useful version of what I've done during each week. After a few weeks, I will start another series on special topics such as Python essentials for Django developers, Linux concepts for web developers, Docker container in a nutshell, or mind and body improvement, self-improvement, and so on and so forth. So without further ado, let's dive into the contents of this week. Remember that simple is always better in the real world. I hope that the content will be useful to you. After this short introduction, I'm going to talk about software creation process, and I'll provide a general overview of how we can build a software, and I will show that software architecture design is just one part of the software creation process. Then I will talk about web application architecture and provide different architectural design approaches. After that, I will talk about software stack, and then I will provide some tasks that if you want to learn more about software architecture and stack, you can follow those references to increase your knowledge in this regard. And life is not just coding and working, but most of us have to sit on chair and work a lot. So it is required for all of us to take care of our pelvic floor muscles. So in this short section, I just provide some links and to let you know the exercises that you can follow in order to increase the strength of your pelvic floor muscles. And finally, I will provide a review of the materials in this section and conclude this presentation with some useful points. So let's start with the software creation process. Okay. Now let's see how we can create a software, or what is the software creation process. And building software is not just coding, and coding is only one part of the software creation process. In general, we can divide software creation process into 7 different phases or 7 different stages, that the output of each stage is the input to the next stage. So in general, we have 7 stages for software development. The first stage is the requirement analysis phase. And for example, for the Collabshare platform, we need to have various login methods. We need to have push notification capability or news feed section and various other components that we discussed in previous videos. The next phase is feasibility analysis. And again, for the Collabshare platform, it is feasible to have a social network platform, because Collabshare is just another type of social network platform, and you know, nowadays there are a plethora of social network platforms working and exist out there. So Collabshare is just another social network platform with new capabilities. So it is feasible to have this project. The next phase is the architectural design phase. So in this step, we want to actually define the blueprint or layout of our software project, and it is one of the most important sections of software development. And in this video, we will talk about this section from a high level view. After the architectural design, the next phase is just coding. So we start coding. So the next phase is software development phase or coding phase. And in this stage, we start coding our application or business logic using various programming languages such as Python, JavaScript, Java, and many other options. After completing our software development phase, we need to test our application. So before deployment, we need to test application completely for different stages. For example, we need to test the database section of the application, the logic of the application, the interface of the application before any deployment. Because you know, if our application has lots of bugs and faults or crashes, no one will love our application, and users will remove the application from their phone or computer instantly. Or if we are developing a web application, they will just hate our website. So we need to consider testing into account. It is vital to the growth and acceptability of our project. After deployment, now it's time to maintenance and upgrade the project. We just need to look to different aspects of our website and just monitor every sections of the website, and if it is required, we need to upgrade it, or we need to change our design pattern or our architecture, or add something new to our platform, and so on and so forth. There are many options in this section based on what we want to achieve. So These are just the 7 stages of software development, and the output of each stage is the input to the next stage. In this video, we will mainly talk about the architectural design phase, and in upcoming videos we will also talk about software development and testing, and we will try to merge these two sections, the software development section and testing section, into one section called test driven development, or TDD. We just need to simultaneously test and develop. In TDD approach, test driven approach, we first write a test code, and after that we write the true application logic to pass that test. So it is one of the best practices in current software development, and it helps us to design reliable softwares. Now it's time to see what is software architecture. But before defining the software architecture, it is necessary to see the different components of an application. Each application is composed of 3 main components, which is described here. As you can see, the first component is data storage and access level. It is where we store application data in our database, and every application actually has some data that needs to be saved and accessed from somewhere. The other component of an application is the business logic or application logic. It is where we can manipulate data. And the final component of an application is a presentation interface, or GUI, or graphical user interface. In this component, we present data and info to the end user, and we enable users to interact with the software. Now that we know the general components of an application, let's see how an application works in general. In real world scenarios, we usually have a client, for example, a user with a mobile phone, and there is a server, and these two entities usually communicate with each other through a communication line. User sends requests to the server, and the server processes the user's request and generates a response for the user. This is a general architecture of how an application can work. Based on where the main functions of an application takes place, we can define the following 3 main categories of software architecture. The first category is as follows. The client communicates with the server, and in fact the database and the application logic, app logic, is on the server, and the only part that is inside the client is the GUI, or the presentation layer. And these two just communicate with each other, and this is the first type of software architecture. You can think of Google Docs in this category. So Google Docs is just an application with this architecture. The second category is again, we have a client and server, but in server side we have database and also app logic. But on the other hand, in the client side we have the GUI and some parts of the application logic. An example of these types of client and server architecture would be, for example, Thunderbird, the mail server. So we can think of Thunderbird in this category. And the third category is, again, we have a client and server, but actually the server in this architecture actually do nothing, and the whole components of an application, database, app logic, and also the presentation layer, all are inside the client section. And we can think of, for example, iMovie or OBS or any other softwares that we usually use, for example, Microsoft Word or Excel. We can think of these applications in this category. In general, the first category of application is called server-based application. So this is server-based application because whole the process is done in the server side and the client is only the presentation layer. The second category is called client server architecture, and in this architecture some parts of the logic is done in the client side and some parts is done in the server side. And the last architecture is the client based, because all the logic and database, everything is on the client side. It is also called peer-to-peer architecture. These are the three main categories of software architecture. One of the most important parts of software development is defining the blueprint, layout, or structure of the software. Software architecture shows the structure of an application. The web app architecture describes the major components of a web app, their relationships, and how they interact with each other. The fundamental building block of the web is the client-server architecture, which we discussed in the previous slide. And in general, web application architecture can be categorized in three main types: monolithic architecture, microservice architecture, and event-driven architecture. Now let's examine each of these three types in more detail. Let's see how monolithic architecture look like. Monolithic architecture is also called multi-layer or multi-level or multi-tier architecture, and sometimes it is also called n-tier architecture. In this type of architecture, we usually have a big server that is responsible for many tasks, and this server usually breaks down into different layers, such as, for example, we have here a three-layer architecture with web server as the first layer, app server as the second layer, and database server as the third layer. Clients, for example, this is a client, mobile client, and this client sends a request to the server. The web server, which is sometimes Nginx or Apache, receives the user's request and sends it to the lower layer, which is the application logic, and sometimes the application logic requires data from the database server, so requests a data from database, and the database responds to the app server. App server completes its functions, his processing on the data, and returns the response to the web server layer, and web server layer sends the response to the user. And as you can see in this architecture, we have a layered functionalities inside a big server. Now let's see what is microservice architecture. But before starting this topic, let's review the monolithic architecture. In the monolithic architecture, the software is highly coupled. In other words, every part of the software is just one piece of a big program, and so it makes it hard to scale monolithic applications. And at the same time, the monolithic applications is not so reliable, because every single fault in the application will make the server to not work properly, and actually the server will shut down and the website will not be available. So it is not so reliable architecture. On the other hand, the microservices architecture is actually here to solve all the limitations and drawbacks of the monolithic architecture. But also it creates other problems that we have to solve. But in general, the monolithic architecture can be described as the following diagram. If this is a client that communicates with the server, sends requests and receives responses, the server is in general composed of different subservices, each of which is responsible for different tasks. So each of these services have their own logics and databases. So in this architecture, for example, we have 4 services and 4 databases. Each service has its own database. In this architecture, as you can see, everything is modular. So we have service 1, service 2, service 3, and service 4. And the communication between these services is done via APIs or any messaging mechanism. So this is a highly modular architecture. It solves the limitations of the monolithic application, but of course there are other problems that we should consider when we choose this architecture for our application. Typically, microservices are used to speed up application development, and containers have a great role in this architecture. In other words, each of these services can be implemented inside a container, for example a Docker container, and we can implement their connections using APIs or any other messaging mechanism. And the third category is the event-driven architecture. In this architecture, we use events to trigger and communicate between decoupled services, and it is mostly used in modern application that is based on microservices. So in fact, we have event-driven microservice architecture, and in future videos we will talk more about this type of architecture. Now the question is, what is software stack? In fact, all the software that we need for running the application is called the software stack. For example, consider that we have a server, and this server is based on Linux, and also we use Django as our Python framework for developing our application, and also we use Nginx and many other softwares to create our application. So every softwares that we use for our project is called the software stack, and in upcoming videos we will decide about the software stack for the Collabshare platform, and after that we just start developing our platform. But at the moment you should only need to know that every software that is required to enable our server, our website to work is part of the software stack for the project. Now that we are at the end of the session, these are the tasks that you should follow if you want to establish your own online business from zero to the end. You need to know more about software architecture. What I have provided in this video is just a high-level overview of different architectural patterns used in current software development practices. But you need to know more about software architecture and choose the one that is more appropriate for your own project. Also, you need to decide what software stack you want to develop your application with. In this video I talked so little about software stack, but in future videos, when we are going to select the software stack for the Collabshare platform, we will talk more about this topic. Another important topic that you should pay most attention to it is the microservices architecture. And microservices architecture in conjunction with containers and event-based systems provides a good scalability feature for our platform. Also, you need to know more about system design principles. This is a topic that I couldn't talk a lot about in this video and also the previous video, but the scalability, the software architecture, the client server mechanism, all of these basic definitions and concepts are related to system design principles. So you need to be master at system design concepts, and that's it. Life is not just working and coding. We have other responsibilities and tasks to do. I have provided some useful links related to pelvic floor strengthening, as it is so important for those who are sitting a lot on chair, such as us, who want to develop their ideas and implement them in practice. So please visit those links and do some exercise so that you will be healthy and powerful enough to continue your dreams. In this video, we talked about software architecture and also software stack, and we looked at different software architecture patterns, such as monolithic architectures, which we also called multi-layered or n-tiered applications, and also microservices and event-based applications or architectures. And we told that event-based applications can be used in conjunction with containers and microservices to provide a higher level of scalability, and it is the practice that is used in modern application development. Also, we talked about pelvic floor and strengthening the muscles in this area. For the next session, we will talk about the software stack and also system design principles of Instagram, and we will see how those principles can be used in our own software development practice. Be safe and see you soon.